Well, good evening. Welcome to Space Oddities. Thank you for joining us this evening. Hope you're all well, and thank you for being here this evening. We've got the rather strange case of a discovery orbiting a red dwarf, 73 light years away. It's being called an exomoon, but it's opened up a whole can of worms. So it's really interesting. So we hope you enjoy that. Joined this evening by the usual suspects. Hi, Roger.
Good evening.
Hi, Michael. Hi, Daz. Hi, Dave.
Hello.
With us this evening because he's hosting a group of people for the eclipse. They've done a cruise. He's now going around Spain. So he hopes to be joining us tomorrow for our Space Oddities live stream. For the eclipse. We'll tell you about that in a little while. We've got the usual features tonight: space numbers of the week, Dave's week in, and etc. So before we go any further, let's just see who's in the chat. Hi, everybody. Oh, good showing tonight. Hi, Pauline. Hi, Deep Burrito. Hi, Heidi. Hi, Ian. And we hope more will join. Okay, well, let's get straight on. And as I said, there's been this rather interesting discovery around a red dwarf star, 73 light years away. So this is going to be really, really interesting to tell you about. So let me just get this up on the screen for you, and we will have a look. 1 second. Okay. Okay. So really what this discovery is really all about is the whole business of scientific taxonomy, the business of categorizing things, objects, living beings. So in science, the whole of science rests upon being able to categorize things, whether it's a bird, a flower, a planet, a mineral, and an insect. So, you know, all scientific classification relies on being able to pigeonhole things, if you like. But what would happen if we weren't able to do that? What if we were unable to look at something and put it into any sort of category? What would happen to science then? And this is the question that this latest discovery raises. So what is this discovery? It's a moon that breaks all the rules. And the system in question has the snappy title, of course, of CD 352722. And it's a system where we have a red dwarf star, 73 light years away. It's got a companion, and that companion is a brown dwarf. And around that brown dwarf, scientists have discovered something orbiting the brown dwarf. So this is a system where the familiar categories of star, planet, and moon no longer fit comfortably. So this is in the southern constellation of Vela. It's a red dwarf star orbited by a brown dwarf, and that brown dwarf is itself orbited by an object with roughly the mass of Jupiter, about 0.9 the mass of Jupiter. Depending how we define it, that third object could be called a planet, a moon, or simply a satellite. Its discoverers are calling it an exomoon, but is that really the best label to stick on it? Now, up to now, as you probably know, astronomers have confirmed more than 6,000 planets beyond our solar system. They include things like hot Jupiters, super Earths, mini Neptunes, and worlds unlike anything orbiting the sun. Yet no exomoon has achieved universally accepted confirmation. This is somewhat surprising because moons are extremely common in our own planetary system and surely should also form elsewhere. Exomoons are, though, obviously extraordinarily difficult to detect. A moon is smaller and fainter than its host planet, which, of course, in itself is vastly fainter than its star. Transit searches, where the planet passes across the face of the star, must identify the signal of a moon within or beside the already tiny signal of a planet. Direct imaging is still harder because the objects appear so close together at interstellar distances. So the exomoons are very, very hard to find because they are so tiny in relation to, usually tiny in relation to a planet. Obviously, we have bigger moons like our own and Pluto's moon Charon in our solar system, which are, a substantial size of the mass of the parent planet. But they are at interstellar distances and small. So this is why we can't find them. Now, this star CD35-272, it's a comparatively inconspicuous red dwarf, approximately 73 light years away in the constellation of Vela. As I said, it's got around half the mass of the sun. Red dwarfs are, as you probably know, the most numerous stars in the galaxy. But this otherwise ordinary star possesses a companion system with no close equivalent in our own solar system. Orbiting the red dwarf is a brown dwarf with approximately 37 times the mass of Jupiter. Brown dwarfs form an intermediate population between planets and stars. Now, this object is too low in mass to sustain ordinary hydrogen fusion, but far more massive than the giant planets with which we're familiar. Here we see the system. The red dwarf is on the left with the star at the middle, where the brightness has been masked so we can actually image it okay. The brown dwarf itself is indicated by the letter B. There's a background star in the distance, which plays no part, obviously. But obviously, we can't directly see the object orbiting the brown dwarf. So let's just sit back a minute and think, well, is a brown dwarf actually a star? Can we define a brown dwarf as a star? Well, the dictionary definitions of a star go like this. A star is a celestial body that generates light and other radiant energy and consists of a mass of gas held together by its own gravity. That's fine. In which the energy generated by nuclear reactions in the interior is balanced by the outflow of energy to the surface. And the inward directed gravitational forces are balanced by the outward directed gas and radiation pressures. Now, it fails on that because most brown dwarfs do not have any type of nuclear reactions in the interior. So we cannot classify brown dwarfs because they have nuclear reactions in the interior, because they don't, generally. Another definition, any of the celestial bodies visible at night from the Earth as relatively stationary, usually twinkling points of light. Well, that's obviously not the case here. And something regarded as resembling such a celestial body. So by that different definition in the dictionary, and all dictionaries give a very, very similar definition, we have to conclude that a brown dwarf is not a star. Therefore, the CD35-2722 system cannot be described as a binary star system because one of them isn't a star. Okay, well, let's ask the question then, is a brown dwarf a failed star? You often hear brown dwarfs described as failed stars. Well, defining something by what it has failed to be rather than what it is really does indicate a failure of taxonomy. After all, we don't call a moon a failed planet. So defining something by what it isn't rather than what it is, to me anyway, makes no sense. So something is going wrong with our taxonomy here. Then, of course, we can ask the question, is a brown dwarf a planet? Well, a brown dwarf is not generally considered... finger trouble. A brown dwarf is generally not considered a planet because it forms more like a star through the collapse of a gas cloud rather than within a planetary disk. It's more massive than most planets, typically about 13 to 80 times Jupiter's mass. Unlike true stars, it cannot sustain ordinary hydrogen fusion. Now, the exception I mentioned earlier, there are some brown dwarfs which briefly fuse deuterium, not hydrogen. which planets cannot. So the distinction is not perfectly clear. Mass composition and formation history can overlap. Therefore, brown dwarfs are usually treated as a separate class between giant planets and low mass stars. And our conclusion, therefore, must be that a brown dwarf is not a planet. Now, this mysterious third body, it's got about 90% the mass of Jupiter, and it completes an orbit around the brown dwarf approximately every 170 days. Dynamically, it's a satellite because it orbits the brown dwarf. Physically, however, its mass places it firmly within the range normally associated with giant planets. So physically, the object is a planet, but dynamically, it's a moon. So how do you think this object should be categorized? Put it in the chat. Should we call this a planet? Should we call it a moon, or should we call it something else? How was this thing found? Well, the observations were made during the CI-RES plus high-resolution infrared spectrograph on the European Space Observatory's Very Large Telescope, the VLT in Chile. The researchers obtained 26 observations between October 2023 and February 2026. The object couldn't be photographed directly. Its presence was inferred by measuring the motion of the brown dwarf, the so-called parallax method. Now, the team looked at this, and as the companion and brown dwarf orbit their common center of mass, the brown dwarf moves alternately towards and away from the Earth. And this movement towards and away from the Earth can be detected because the spectral lines shift slightly towards the blue and then slightly towards the red. And this can be measured by a spectrograph. And this produced a repeating signal with a period of approximately 170 days. So something is definitely pulling on that brown dwarf, causing the star to move towards us, and causing the brown dwarf to move alternately towards and away from us. But this periodic signal is not sufficient. The researchers tested whether it could have been produced by two smaller companions, atmospheric or rotational variability in the brown dwarf, some sort of pulsation, or an instrumental artifact. But when they took all of those things into consideration, they managed to eliminate all of them except the best fit for the data, which is one massive satellite orbiting the brown dwarf. The study was led by Kevin Hoy, an ESO student in Chile, who is also affiliated with the Universidad Diego Portales and the Millennium Nucleus of Young Exoplanets and Their Moons, known as YEMS. This is a group that study young exoplanets and their moons. The collaboration included Alice Zerlo, the director of YEMS, and an astrophysicist at the Universidad Diego Portales. So they're the people who made the discovery. And Kevin Hoy summarized the result very directly. This system is super weird compared to our own. And this is really scientifically appropriate. Our solar system presents a comparatively orderly hierarchy. Planets orbit a star and moons orbit planets. CD352722 replaces that familiar sequence with a star, a brown dwarf, and a Jupiter mass satellite. Now, this companion is not a small rocky moon. Its mass is roughly that of Jupiter. And Jupiter, of course, we regard as the dominant planet around the sun. And it occupies the role of a satellite in the case of this star system. This demonstrates that an object's classification can depend as much upon its orbital relationship as upon its physical properties. But just think about that for a second. Going back to what we said about taxonomy, instead of defining objects based on their characteristics, we're now having to define objects, at least partly, based on their relationship to other objects. This is like defining a duck based on its relationship to fish. So again, it's a taxonomy problem. This system developed from the architecture of the solar system. A star was the central luminous body, planets orbited it, and moons orbited those planets. Straightforward enough. But here, the intermediate object is a brown dwarf, neither a star nor a planet, while its satellite has the mass of a major planet. So this is all very, very confusing. The paper explains the problem clearly. It reads, we have a clear delineation between the planets and the sun in the solar system, so defining things like moons is simple. In the CD352722 system, where we are blurring the lines between stars, planets, and moons, the whole thing becomes more complicated to describe. But it's not the first time that astronomers have thought they've discovered an exomoon. The previous example was HD 206893, following a discovery by Quentin Kral using ESO's VLT again. And that research produced indications of a possible satellite, but not a firm detection. They weren't sure. It could have been an exoplanet, but the data was really not there to support it. But it does indicate that brown dwarfs may provide particularly promising targets for the emerging search for these exomoons. And why is that? Well, brown dwarfs offer an advantageous compromise for this kind of search. Firstly, they emit enough infrared light for high-resolution spectroscopy, yet they're much less massive than orbiting star or ordinary stars, and can therefore be moved more noticeably by a massive companion. So we can see them wobbling because their low mass means they can be pushed about, if you like, by anything orbiting them if they're a massive companion. Also, widely separated brown dwarfs may also be easier to isolate observationally from the glare of their parent stars. So brown dwarfs are prime candidates for looking for these exomoons because they do offer certain advantages. So in this case, it's important to distinguish the observation from its interpretation. The telescope measured a repeating radial velocity variation in the brown dwarf. Orbital modeling indicates that a massive companion is the best explanation. What remains less straightforward is the terminology. Calling it a moon describes its orbit, while calling it planet-like describes its physical scale. Obviously, the team have got further observations planned to strengthen the idea that they've discovered an exomoon. They need to refine its mass and exclude any remaining alternative explanations. Similar searches can then be extended to other young brown dwarfs. More sensitive instruments and ESO's ELT, the extremely large telescope, coming online towards the end of the decade, should reveal whether systems of this kind are rare or widespread. But what you may say after all this is, so what? What does all of this matter? The problem that we have is that we are in distinctly unfamiliar territory with this problem of categorization. It reminds us that the words star, planet, and moon were created from a sample of one planetary system. As observations become more sensitive, nature is revealing arrangements that cross those familiar boundaries. This object may prove to be an exomoon, a planet-like satellite, or part of a new category. Whatever name prevails, the system itself is real and profoundly unfamiliar. And we have a good example of this. Pluto is the most famous of these, of course. When it was discovered in 1930, it was immediately accepted as the ninth planet. But as astronomers found more objects beyond Neptune, some approaching Pluto in size, it became increasingly difficult to justify treating Pluto as unique. And as we know, in 2006, the International Astronomical Union controversially voted to reclassify Pluto as a dwarf planet. But the important thing is the controversy was not about Pluto itself. Pluto had not changed. What had changed was our knowledge of the population around it. A category that had seemed perfectly adequate and reasonable when only one object was known became increasingly difficult to defend when many similar objects were discovered. And this is a case we're all familiar with, of course, with Pluto. The deeper problem is that nature does not always provide sharp boundaries. Stars, brown dwarfs, and giant planets form a continuum of mass, temperature, and composition. We often distinguish them by whether they can sustain hydrogen fusion, briefly fused deuterium, or never undergo fusion at all. But even those boundaries depend on composition and formation history. And we have the same difficulty among planets. Where does a rocky super Earth end and a gas-rich mean begin? At what does a giant planet become a dwarf? Is an object defined by its mass, external physics, the way it formed, or what orbits? These categories are used objects to try and categorize them. We try to decide where to place those dividing lines, and as we're increasingly discovering with other star systems, these lines, these dividing lines, are rarely as clean as the name suggests. And the discovery of now 6,000 exoplanets has made the problem much more obvious. Before the 1990s, our taxonomy system was based entirely on the solar system that we know. But now we know thousands of planetary systems looking nothing like our own. We found hot Jupiters, like the one shown here, skimming the surfaces of their stars, super Earths with no equivalent in the solar system, mini Neptunes occupying the gap between Earth and Neptune, planets orbiting two stars, planets orbiting stellar remnants, planetary mass objects apparently traveling through space without any star at all. Every discovery expands the range of possibilities, but it also weakens the idea that rigid categories can capture the full diversity of planetary systems. And of course, the more of the universe we see, the more it appears to resist our attempts to sort it into neat, tidy boxes. And this is not an isolated exception, this system. It's part of a much broader pattern. It's also part of a growing problem. What we discover in the universe is increasingly beyond our capability to categorize it. So there you go. That's the problem of CD 352722. Anybody got any comments?
I certainly was, when you started talking about this, was reminded about the planets and Pluto and at the time, how obvious it was becoming that category either was not going to work for planets or was just going to be so flooded with these objects in the Kuiper belt that it was going to start losing its meaning, I guess. I remember at the time thinking, for that, it was kind of like on Earth, we have continents and we have islands, and Australia is a continent and Greenland's an island. I mean, they're really the same. I mean, they've been formed the same. It's just fine. There's just a cutoff. But we know everything on the Earth. We're not going to discover something between Greenland or Australia and say, oh, no, we don't know if this is a continent or an island. So we don't have that problem. But, it's a similar kind of problem. I mean, a lot of these things are, the objects are very much the same, and it's just the size. I mean, one good cutoff, I guess, is if it can sustain nuclear fusion, makes sense as a good cutoff for a star. Yeah. But brown dwarfs muddle that. So
I mean, who's to say that our solar system is the norm? Ours might be the exception, and everything else that we think is the norm.
Yeah, absolutely, Roger.
Exactly. That's what we mean. Yeah.
We are learning that our solar system appears unique at the moment because no other star systems we've seen, with the possible exception of the TRAPPIST system, look anything like our own. But of course, the TRAPPIST system, all the planets are very, very close to the star.
Right.
We've got no direct analog with other star systems. The problem is, of course, is one of statistics, because if you want to do statistical analysis of exoplanets, you've got to come up with categories to properly place it, and if we're failing to do that, we won't have a clue what's going on. So anyway, let me just look in the chat and see what some of you were saying. Derek says Jupiter's a failed star similar to a brown dwarf. Jupiter has lots of moons, therefore is a moon. Yeah, good point.
Well, no, I disagree with that, because Jupiter is a gas giant. It never achieved enough mass to even contemplate being a brown dwarf.
No, absolutely.
And then, of course, if it achieved enough mass after being a brown dwarf, because remember, the idea is a brown dwarf is a huge planet, gas giant, that did not achieve enough mass to sustain fusion at its core. So, as I said, I see Jupiter as a giant, a gas giant And brown dwarfs is a completely different object. But of course, if Jupiter had gained more mass, and it could have even become a star.
Yeah,
So,
I mean, but the thing is, Jupiter would have needed at least 80 times its
yeah,
mass
exactly.
to become a star. So it was never going to be anywhere near a star. And I don't think that calling it a failed star can be correct. You know, you may as well say the light bulb in my bedroom is a failed star because it hasn't got enough mass to generate fusion.
Okay, but at what point does a planet become a brown dwarf? I mean, what?
Yeah,
exactly. That's what we mean. Yeah.
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 That's
I mean, the thing is, we call them planets, but like I said, they've got their own descriptions. We've got the rocky planets, then we got the gas giants, then we got what we call the icy world, which again are gas giants, but where most of it's frozen out, and things like that. So we've sort of like clumped everything together as and this is where I think where Andy's getting at, is that because we clump everything into planets and stuff like that, instead of using the larger scale of what these things actually are, this is where the confusion lies. Because I mean, you've obviously got a massive gas giant, which is the brown dwarf, being orbited by a smaller gas giant, which is a mini Jupiter. So it just we've got, like I say, it's getting the definitions sorted out. We've got to, because really, in theory, the mini Jupiter is either a satellite of the brown dwarf or it's a moon.
Yeah.
So, you know, that's the only, if you want to simplify it, that's what it is. But in theory, it doesn't work that way and such if you want to be more specific.
No, that's right.
So,
That's right.
yeah.
And as the International Astronomical Union is the body responsible for creating these categories and plonking objects in them, you can imagine them holding another conference and many conferences to try and work this out. I mean, it's going to be, you know, there's going to be resistance to whatever you decide to do, basically.
Well, the thing is, when they did the definition of a planet, they actually made a faux pas in the fact that they said that a planet must orbit the sun.
Yeah. Yes,
well,
that's
the
true.
sun is in our solar system, so that means all these other systems we're finding, you haven't got a sun or planets, because the planets must orbit our sun.
That's right.
So it's a whole, but you know what I mean. That's just being a bit flippant.
Barry says a brown dwarf can fuse. Yes, as I said, some brown dwarfs, if they have enough mass, can fuse deuterium. But it's only a very, very brief phase because they actually haven't got a lot of deuterium to fuse. So it doesn't last very long. So if you were to look at it on a particular day and see it fusing deuterium, and then, you know, look at it on another day and it isn't, you know, how do you classify that? I don't know.
Yeah, it hasn't got the mass to move on and sustain it. So
so I guess my very naive question then is, I guess, let's think of the best way to put it. Why is Jupiter not a brown dwarf? I mean, what is it that keeps it from being
get that close to a brown dwarf? You need
is it a I mean, okay, so what? I guess I'm asking, what makes a brown dwarf a brown dwarf? Is it just a mass limit, or is it? I mean, it doesn't have to be fusing deuterium, right? That was
no.
It reaches a. I mean, I don't know what they've said it at. It reaches a mass where, if it got any bigger, it could then start to create fusion. But it hasn't gained enough mass. And like I said, I mean, Barry brought up a good point. Yes, they do fuse deuterium, but not for long. So, and in Jupiter got nowhere near that situation. So that's why I refer to it as a.
Okay, so it's just still a pretty fuzzy boundary, but
absolutely.
Everything's a fuzzy boundary.
It's completely arbitrary, you know.
Well, I mean, something actually fusing, you know, a sustained nuclear fusion in its center, I mean, makes it a star that's at least. I mean, it may not last long. I don't know. That's another matter. But I guess we consider that a star, right? That's at least a fairly clean line, right? It's either doing it or it's not. But it sounds like the brown dwarf, it's kind of really big, and if it got a little bigger, it'd be a star, and maybe it'll fuse a little deuterium, but it can't be too small because then, it's just, I guess I'm just trying to get an understanding of this being not an astronomer. So.
Ian says, I get the categories useful, but are they really helpful? Well, yeah, they are, because without the categories, you cannot do any sort of statistical analysis of the populations of planets that we're finding. And Fred says, hi Fred, hope you're well. According to DuckDuckGo, Jupiter would need to be 13 times more massive to fuse deuterium and 80 times more massive to fuse hydrogen. So there could be a definition: 13 times more massive than Jupiter. 13 and I actually think it is about, I think they said 13 to 95 times the mass of Jupiter, if I remember rightly. That's the definition.
Exactly.
So the definition would be something made of gas with that mass range, capable of fusing deuterium, and that's it.
Right. Okay.
Incapable of hydrogen fusion, but capable of fusing deuterium. But anyway.
Yeah, Flint says, what is a white dwarf? Well, white dwarf is actually a star that's died. It's gone through all its phases. It's like a star, like the sun. There's a sun's a star the size of our sun. Basically, we will go through the red giant stage where the atmosphere will expand of the sun. Then eventually the fusion will stop, and then the gravity will take on, and it will all collapse, causing a small explosion. But what you'll end up with, it won't go into a neutron star. It will actually then become basically a cinder.
Yeah.
It's a cinder, and basically it was over the millennia, it'll cool down, and that's what we call a white dwarf. So it will emit heat for quite a substantial time, but that is actually a dead star.
Yeah, and that's how the sun will pass the end of its days. And you're looking at an object which is super hot to begin with, a few hundred miles across, extremely dense. A teaspoonful of white dwarf material would weigh thousands of tons, and it represents the end of the life cycle for stars like the sun.
Yeah,
that's basically it. Thank you for your question, Flint Dibble team. Okay, so let's move on. Thank you all for your contributions to that conversation. I'm sure we'll be returning to this because this problem is getting worse and worse and worse with taxonomy of other star systems. So we're going to go over to Dave now for his weekly look at days gone past and what was happening in the past in space exploration history. Okay, and I don't know if I have anything relevant to our discussion now. Let's see what pops up. Trying to remember. I did these in two parts. I did a week for last week, and I did a week for this week. So I'll just, but I concatenated them all. They're all together. Okay. So anyway, let's go. This is what I left you with 2 weeks ago, I guess, right? As seen on TV, not so baby steps. The satellite gets a sub-satellite. Mars makes messages curiouser and curiouser, and sampling the sun. You may have guessed some of these. So as seen on TV, so August 2nd, 1971, was the first pictures ever of an object lifting off from the moon. And this was done on Apollo 15 because it had the lunar rover. And the lunar rover had its own camera. So they actually set it up so it was pointing towards the lunar module. When they left, they parked it there. And they had the camera pointing towards the lunar module. And they just ran it while the lunar module took off. In the case of Apollos 15 and 16 too, they just had an image, and they had a video. I was having trouble with the video, so I don't have a video here. I wish I did. I should. But in any case, so they just showed it shooting out of the frame. On Apollo 17, what they did was, and this is one of the things that came up as a conspiracy theory, because of course there's
you know, a 1 1/4 second delay each way. So the cameras can be operated from the ground. They were operated from the ground, and but you couldn't follow the thing as it went up because of the delay. By the time you saw it moving and you started moving the camera, you're already 2.5 seconds behind. So you couldn't do it. So what they actually did was they practiced based on when the engines were ignited. And these are these hypergolic engines, which were just very simple engines, because of course they didn't want to take any chances of not getting off the moon, where they just mixed the fuel and the oxidizer in. They were in 2 separate chambers. They mixed them. The minute they hit each other, they ignited, and so they just took off. It was really almost foolproof, you know, a system to get them off the moon. But they watched this from the moment that they triggered it to the moment it went off, and they timed it. And so the cameraman on the Earth actually sent the message to the camera to start panning upward before before they sent the message, you know, before they received the transmission that they were, you know, taking off, or at least, you know, a second after or something like that, before it actually started moving. And they actually caught it. They caught it perfectly. And I'll have to show that on maybe on the anniversary of Apollo 17. Yeah. But they actually panned upwards with the lunar module in the frame. That was pretty amazing. You know, just an amazing bit of work by a lot of people, but pretty clever.
Of course, they did. Dave, nudge, nudge, wink, wink. You know?
Yeah, right. I know. I'm actually surprised you don't hear more about that, because it does seem, you know. But okay. Not so baby steps. All right. So this is August 3rd, 1957 now. So what are we, 69 years ago, was the first successful long-range R7 ICBM launch by the Soviet Union. It actually wasn't a complete success. They lost control of it, but it still went 6,500 kilometers, landed in the Pacific Ocean. And well, okay, so basically what happened now, if you notice the date, was August of 1957. This paved the way for the Sputnik launch. I mean, this was the test, and another test that came right after it, that basically convinced the Soviet Union that their spacecraft, you know, that they would work, that they could take something up to space. And so this was really one of the big major stepping stones of them getting Sputnik into orbit around the Earth. August 3rd, 2004. So yeah, 22 years, a launch of the Messenger mission to Mercury. An amazingly successful mission, the first thing to orbit Mercury, sending, you know, data. I mean, it was packed with instruments, you know, taking information from the surface at every wavelength, and information from the tenuous atmosphere. Just an amazing mission, really. Satellite gets a sub-satellite. Okay, so whoops. Apollo 15 also, and obviously it's the date is related to the fact that it was when it took off. The day after it took off, when it was still orbiting the moon, it released a sub-satellite. This Apollo 15 and 16 had these little sub-satellites, and these were the first sub-satellites that were launched. They launched them, they left, they came back to Earth. The sub-satellite kept orbiting for well, let's see, there were two different ones, but this one was, let's see, now it was orbiting for well, I don't have it here. Okay, anyway, they orbited they were made to orbit for a few months, until January of '73. So it orbited for about 6 months, and it had some equipment to really measure the magnetic field of the moon, or at least basically the solar magnetic field and the Earth magnetic field's influence on the environment of the moon. Measured that, and the thing about that was you could have a small satellite away from the main spacecraft, which of course was full of metal and were very difficult to measure magnetic fields with all that metal in the vicinity. So this was a good way to measure that, and they could measure it obviously for a long time. They could do it for 6 months. They weren't going to keep the astronauts up there for 6 months. Also, they carefully tracked it and used it to measure the moon's magnetic field. They're very successful little satellites anyway. These sub-satellites, and they were just kind of just launched off of the Apollo spacecraft. Okay, launch of the Phoenix lander to Mars, and you probably remember this. It landed in May of 2008 up in the Arctic plains of Mars in Vastitas Borealis. Lasted until November of 2008. Returned a lot of data. It dug trenches. Kind of the first pictures of subsurface ice, and discovered perchlorate, which kind of turned some of the the arguments about life on Mars on its head, because this is quite a toxic kind of chemical, and was considered that if this chemical was there, it's be very, very difficult for life to exist, at least where this chemical was, and maybe it's only in certain areas. But it did turn that, but also turned out that it could be a possible source of energy for microbes, depending on the microbes. So it added quite a lot to a lot of fuel, I guess, to the fire of the idea of life being on Mars at any point. And they Korean Pathfinder Denori, the lunar orbiter, launched from Cape Canaveral, but this was a completely Korean mission, South Korea, and it was inserted in orbit around the moon on December 16th of 2022. Still operating now, has a bunch of cameras, a gamma ray spectrometer, magnetometer. So another international, another country gets into the act of studying our solar system. The Mars mixed messages. Okay, so August 5th, 1973, going way back, launch of the Mars 6 atmospheric probe. This was the first probe to return data from the Mars atmosphere. So it's the first thing to actually go in and worked and return data from the Mars atmosphere. The reason I put mixed messages there is that a bunch of the transistors failed before it got there. And this was part of an armada of missions. Mars 4, 5, 6, and 7 all went. Mars 4 and 5 were orbiters. Mars 6 and 7 were landers. But early on, after they launched these four all almost around the same time. Because the thing about Mars is you need to launch. You only have these every 2 years you get a window where you can launch to Mars, basically. And so they launched these four all about the same time. As they were on their way, they started noticing problems with different ones of the missions. And they finally traced it to a faulty batch of semiconductors, actually, that were used in all of the missions. And they started failing one piece of one spacecraft at a time.
Oh dear.
They started realizing, as these things were flying through space on Mars, and there was nothing they could do about it, that major parts of these were going to fail and we're not going to make it to Mars. And that's exactly what happened. Parts of them worked, parts of them didn't work. Depended which semiconductors failed and when they failed. They did lose communications and things like that. What happened with this one is that it actually worked. It stayed it stayed operational. It dropped off the lander. The lander went into the atmosphere. It returned data over 224-second descent. So about 4 minutes going through the atmosphere on a parachute. But a lot of the data were corrupted because of the bad semiconductor. So they managed to sort out what data were real, and they did return some data, but a lot of it was lost. A lot of it was corrupt, and it was supposed to land softly, and it did not. They don't know exactly what happened in the end, but the communication ceased abruptly, and presumably something didn't work that was supposed to work. And it just crashed.
Just saying about that, Dave. This is why we had this conversation a little while back. I think we were talking. I can't remember what we were talking about now, but why a lot of these probes and all that use sort of like historic equipment, transistors and everything. Things that
Yes.
have been proved to work, they use rather than actually put something on new that will possibly fail.
Well, yeah, no, that's true. I mean, at NASA, there's kind of a rule that stuff has to be, you know, tested and working for a few years. And I don't know exactly what the rule is. You know, it's probably different for different types of components, but they won't take the latest computer chips and that sort of thing. So it's always kind of a, you know, we would always hear, you know, kind of jokes about, well, why are you using this old, you know, 3-year-old computer chips? They're so much better now and stuff. It's because we don't know if they're going to work in space. And,
they're proven.
You know, no one's going to take a chance. We'll go with the with the proven technology, even if it's not supposedly as good as what we've got. So yeah. But it's true. But I just imagine these guys, right? The missions are going and all of a sudden something fails and they're like, oh, or you know, whatever failed on this mission. And then they get something for another mission and, you know, the magnetometer failed. And then they start looking at what's failing and what's happening and they trace it back to this one. And I guess they got the rest of the semiconductors and tested them and realized they were faulty. And so they were just watching as these things went to Mars and knowing that things were just going to start failing. Must have been not much fun.
I think it's Europa Clipper. I could be wrong. It's one of the probes that is on its way out to Jupiter. They're a bit concerned about some of the components on there because they weren't tested enough, and they're not sure whether they'll survive the magnetic forces produced by Jupiter. So it's sort of like it's on its way now. So there's nothing they can do about it.
Right.
But
I didn't. Yeah.
This is nagging in the back of the head. Will they be able to survive?
It's a type of transistor they're using on the spacecraft that is they think may not be sufficiently radiation hardened.
Yeah.
Oh boy. Well, I mean, that was the big. Of course, that was the big word with Europa Clipper, right? You can't go orbiting Jupiter if you're not really protected against radiation. But I didn't know that specifically. So that's interesting.
You see, the Europeans don't have this problem because the Jupiter Isomoons Explorer will orbit around Callisto and Ganymede as well. So it won't be in the most intense part of Jupiter's radiation belt.
Right.
Hopefully that will be okay.
Yeah. Okay. Well,
but
anyway,
next time, NASA, don't buy your transistors from Tamu. I mean, that's a bit of a no-no, really.
It's good advice. Good advice. Yeah. Oh, just real quick. August 5th and 6th, back 1969, Mariner 7 flew by Mars. That was a companion to Mariner 6, which I think I talked about a couple weeks ago. Same basic, exactly same spacecraft. They launched a pair of them. The launch of the Juno orbiter Jupiter was another very successful mission that, you know, so some of the amazing pictures of Jupiter from that I'm sure you've seen. Zond 2 flew by Mars, only 1,500 kilometers, but had already lost communications, unfortunately, before that time. And I don't know if they know why. I think it just went dark, and they never knew why they lost communication. Cursor, you could probably guess this. Curiosity rover. It landed on August 6, 2012. So yeah, if you're feeling old, that was 14 years ago. The 7 minutes of terror and the whole thing.
That was when I won the bet with my brother-in-law, who's an engineer, who said it was impossible that the sky crane would work.
Okay. Yeah, I guess you did mention that. That's right. Yeah. Anyway, I just a fantastically successful mission. I worked with the guys, not on it. I mean, they work in the same hallways. They're my friends. I'm not going to take credit, but that developed that built the SAM instrument. Which is really the most sophisticated laboratory chemical laboratory ever sent off the Earth. And this thing, this Curiosity rover, it was like the size of a small car. I mean, a very, very small car, but it's a car nonetheless. It's a big old thing, and you can see the track. I mean, it's just going and going. Let's see, I had written down the statistics for it. It weighs about 900 kilograms. But it and it's and I should say this, it explored it landed in Gale Crater, explored Gale Crater, and then it went out. It went along these areas of dunes, and then it crossed across them and climbed up Mount Sharp. It's actually changed its elevation over 740 meters. It's climbed since it landed from its landing point. It's climbed 740 meters, and it has driven over 36 kilometers, over 4,982 sols, which are Martian day, which are close to an Earth day, but we're talking about
and
well over 5,000
all of that
days.
traveling has really damaged its wheels.
Yeah.
And like this is the damage to one of its wheels.
Well, it's still got a few miles in it.
Yeah. but they learned their lesson.
Wow. Yeah.
That's the MOT though.
Yeah. They learned their lesson when it came to designing the Perseverance rover, which they completely redesigned the wheels, so this type of damage hasn't happened to Perseverance to the extent it happened with Curiosity.
That's
So,
amazing, though.
Yeah.
That's amazing. Yeah, I had not seen that picture actually, so that's
a recent picture. I think it was released last week.
okay.
So
and yet it's traveled.
It's still going
36 kilometers and still climbing up Mount Sharp.
Yeah.
So and it's just sending back fantastic pictures like the one on.
It's only a scratch.
It's only a scratch. Yeah.
A great meal.
Is
a
it
great
Perseverance where they've got in the tread, they've got the coordinates of one of the NASA centers?
They had a code, right? They put like in Morse code or something, JPL, I think, or something.
Yeah.
Well, NASA had made a rule. They did this thing a while back. I remember when they did it. They wanted to set it, things have to be one NASA. We have to stop competing between the centers, and it has to be one NASA. So they stopped them putting Goddard Space Flight Center, JPL, things like that. At least on the missions where the cameras could see it. In other words, they didn't want people like advertising and stuff. I guess basically, and I guess at JPL they put this in the rover wheels just so they could. They could have their little snub their nose at it.
And also, weren't the parachutes have in sort of like a binary thing in Dare Mighty Things or something like that?
Oh, that was.
That I hadn't heard, but
that was the message on the parachute, wasn't it?
On the parachute,
I heard that one. Yeah.
Okay.
Yeah.
There was a bit of a competition going on who could do it first, but people who did it within sort of like 2 or 3 minutes after seeing the parachutes come down from the actual.
Okay. So that's a new one, and they snuck that in there. I'd heard about the wheels, the wheel treads, but that's okay. Here you go. Okay, European Space Agency Rosetta. Rendezvous with Comet 67P. Oops, and I lost. Oh well, how did I do that? Okay. 60P Churyumov Gerasimov CG, right? 67P. I talked, I guess, a while back about the Philae lander and a little bit about the mission, so I won't go into it in that much. But this was August 6, 2014, when it actually made its rendezvous with the comet and started all its operations and the Philae lander and all. All right, now we're going back 1576, August 8th. The cornerstone laid for Uraniborg. Which was Tycho Brahe's observatory, by far the most expensive scientific anything that was done up to that point. His observatory, there was nothing that compared to that, and in fact, it was basically a bribe. He was Danish, and he was, but he had plans to move to Switzerland. And apparently King Frederick II of Denmark offered him an island and to build this observatory for him if he would stay in Denmark. And he was so well known at the time that the Danes didn't want to lose him, and so he accepted. And they built they gave him this island, and they built this giant observatory, which of course Tycho Brahe made pretty good use of. Yeah. But that's funny. That was something I didn't know. And so we're but there we go. So yeah, 450 years ago, just a few days ago, 450 years ago, they laid the cornerstone and started building this.
Wow.
Yeah. August 8th, 1978, launch of the Pioneer Venus probes. I guess I've talked about this before a little bit, but the Pioneer Venus mission was launched in two parts: an orbiter and a probe. Launched pretty close together. The probe had a bus. It had 3 small probes and 1 large probe. And when it got to Venus, it released all these probes. They all plopped down in the atmosphere in different places. One on the night side, one on the day side, one on the sort of the northern area. And just made measurements of the atmosphere all the way down to the surface. Another amazing successful mission. The probes all worked and all returned the full complement of data that they were supposed to, and that's how basically our best understanding of the Venus atmosphere and the profile of the Venus atmosphere comes from these probes and the clouds. Sampling the sun, you may have guessed this one. If you remember the Genesis Solar Wind Sample Return mission, it was so August 8th, 2001, it was launched. 25 years ago, a few days ago. Maybe what you remember about this one more is that it didn't land successfully.
Yeah, it split open.
Yeah, so first off, what it had were all these different panels. And the panels were made of different materials: sapphire, ruby, just a lot of different materials to collect whatever they could of the solar wind. And they'd expose these to the solar wind. The thing orbited out there and just as it was exposing itself to the solar wind and collecting all the particles that it could. It closed them all up, sealed it up, and then dropped it down to Earth. It was supposed to, when it hit the atmosphere, an accelerometer was supposed to basically tell it, okay, you hit the atmosphere and release your parachute. The accelerometer was installed upside down in the probe. That is what happened. And so it never knew it hit the atmosphere. It was waiting for a shock in the other direction. The parachute never opened, and it crashed in the desert. Now, I remember watching this live, and they showed it. They had a camera, a really high, high resolution telescopic camera that was watching it come down. So you were watching it. It's coming down. Now, I had already known, about what to expect with this thing, and things seemed to me to be taking a lot longer. A whole bunch of us were sitting there watching it. Things would take a lot longer, and I started saying, I think the parachute should have opened by now. I don't know what's happening. Maybe I'm wrong. And they're watching, and it's just sort of, you can't see anything but this thing kind of wobbling around in the frame as the camera's watching it. The camera's going. I'm going, my gosh, this is really taking a long time. When is this parachute going to open up? Next thing you know, the camera's looking at the ground. There's just the horizon in the distance.
You can just imagine when it hit the ground, all of a sudden the drogue chute just pops out.
Right.
But there was a good result in the end.
Yeah. Yes. It turned out that despite the hard landing and despite what happened with all these panels, where they were shattered, they collected them up, and it didn't really matter that much that they had gotten. They really couldn't get contaminated because what they had were these embedded solar wind particles, which had hit them at very, very high, hundreds of kilometers, a second speeds. So that they were embedded in the thing. The thing crashing on the ground did not ruin what was inside, what was embedded in these things. So they collected up all the pieces, all the shards and pieces of the panels, and they were able to do they said apparently they're able to do 100% of the science they wanted to do, and collect all the solar wind particles and everything. So yes, so it worked out okay, but oh boy, anyway, yeah, not a happy
Barry
day.
says, good thing NASA didn't install my washing machine.
Yeah, that was just one of those, it just happens. It kind of shows you how hard this stuff is, even a simple thing like that.
Because if I remember
actually,
right, all the discs were layered with different materials to collect.
Yeah,
different
like one was a
things,
sapphire, I think sapphire and ruby. One was, they had some different materials, a hybrid material. I can't remember what they all were, but yes, to get different particles, different depths, different speeds, the different, and affecting the particles differently, obviously, not contaminating them.
Yeah.
There was another spacecraft that had the exact same accelerometer on it. And now I can't remember the mission. It was out in space at the same time. So this is kind of comparable to that Russian mission. They were going back over the blueprints and going over everything, all their documents to make sure that the thing was installed correctly. And they decided that it was, and it did work. But but there were some very nervous weeks, I think, when they were, trying to make sure, and especially when it was landing anyway, even as convinced as they were that it was incorrectly, they were still, I think, never sure.
It had one job to do. That's all it did. It had one.
Yeah. Put it in right side up. I think they started designing them so that they weren't symmetric after that.
Okay, thank you very much, Dave.
So do we have time? I've got the next week.
Oh, sorry.
No, it's okay. Do we have time?
Yeah, sure.
Have I advanced though? Oh no, we're back. Okay, yeah. I if you want to pop. Do I need to do this? Pop myself back up here.
Yeah, sure.
Or can you pop it up? I mean, according to this, I'm still sharing.
Right. Hang on 1 second. Okay, just stop sharing and reshare if you would.
Okay. All right. Hang on a second here.
Yeah.
Stop.
Hang on. Oh, I've got it actually. Here we are. Oh, where's it gone? Sorry.
I stopped sharing. All right. I'll grab it again. That's okay.
All right.
Allow to share. Okay.
Sorry, I was out of the room briefly. Did you talk about the daylight fireball?
Not yet. So.
Oh yeah. Okay.
Right. Good. Oh, you're electrician, right? Okay. All right. So the 9th through the 15th, I had given these things. I had these at the end of the last one. Fearsome Discoveries, Radar Love, Lucky 13, our first selfie, and contour lapse. It doesn't work the same when you're doing it right away, but okay. August 10th and 12th, 1877, discovery of Deimos and Phobos. This was our supposedly our fearsome discoveries, but only because they were named after they were discovered. They were named as, of course, Mars was the god of war, and these were named for his consorts, which were fear and dread, or terror and dread, and for Deimos, and panic or flight for Phobos, is what the names mean. But anyway, this was it was quite a discovery. The first. Obviously the first moons of Mars, the only moons of Mars, but he discovered these with a 26-inch refractor, which was the largest refractor telescope at the time, owned by the U.S. Naval Observatory. Of all places, he discovered these in near Washington D.C. in a part of Washington D.C. called Foggy Bottom. If I was going to place an observatory any place, I would not choose a place called Foggy Bottom, but I guess it worked. They did end up moving it.
To Cloudy Mountain.
16 years later, right? They moved it up to Georgetown, there was a note in 1893, hampered by the unfavorable climate of the original location. They moved it to Upper Georgetown. I mean, let's say, I live right there, right? Washington D.C. is not the optimal place for observatory, but in the early days they did what they could, and the U.S. Naval Observatory was right there. So of course that's where their observatory would be. In any case, even with those conditions, he discovered Deimos and Phobos on the 10th and Deimos on the 10th and Phobos on the 12th of August. So,
Just as a bit of useless information there, sorry, Dave.
Yeah.
Deimos and Phobos, do you know they're linked to Gulliver's Travels?
yes.
Yeah, because
I-
in Gulliver's Travels, was his name Swift who wrote it?
Jonathan Swift.
John
Yeah,
Swift, and he predicted something about
yeah,
the orbits or something. What?
yeah.
Go ahead. Yeah.
Lilliputians, the astronomers, predicted that there would be two moons of Mars.
Right.
Because at the time, around this time, they sort of thought, well, Earth had one moon. Then they said, oh, they suspect that Mars would have two, and then Jupiter would probably have either 3 or 4. They think it was incremental.
Right.
So basically, a lot of the craters and areas on these moons are named after characters out of Gulliver's
Gulliver's
Travels
Travels.
and
Yeah.
things like that. So yeah.
Yeah, and
Okay, I do.
he
Yeah.
also predicted the orbital period of both
Yeah,
satellites.
that's right. Yeah,
He was very close, right, to that. Yeah, that, and I had heard
well,
that.
fairly close.
yeah.
I mean, he had 10 hours for Phobos when it's actually about 7.3, but he was completely out for Deimos. So, but I mean, yeah, Daz is right. They were just following, logic about the number of moons that planets should have. So, yeah, quite
Still pretty great. Yeah, still,
Yeah.
it's pretty cool. Yeah, that's right. Yeah, when you said it, the neurons fired, and it was like, oh yeah, I remember. That's right.
Yeah,
It was a thing
yeah.
about that. Yeah. All right, radar love. Well, okay. So Magellan goes to Venus. Another amazingly successful mission. I mean, really, our first really good views of the surface of Venus. The Soviet Union had sent some Venera missions, 15 and 16 there, and gotten some views, but really Magellan had a much more powerful and much higher resolution radar, and mapped the entire planet from a couple different angles, which can make a big difference with radar. Radar interpreting radar images is very, very complicated, because radar just doesn't work quite the same way as visible light. The way it reflects and the way that you have to interpret the reflections, it's not very easy. But incredible images of Venus, and really, for everybody, right? Our first real look at Venus. So quite an accomplishment. Okay, here we go. A great daylight fireball. I'm guessing that almost all of you have seen this image on the left. It's just, I see it everywhere. I remember the first times I saw it, I said, now that's, I want that on my bucket list. I want to see something like this.
Yeah.
I want to be out, out in the, wherever I am, and see a fireball go across a big open sky like that. I think that would just be so cool. But this fireball, August 10th, 1972, this thing flew up from south up to north, flew across Utah, Idaho, Montana, and then into Alberta. It turns out it was don't know exactly, something between 10 and 50 meters across, depending on whether it was a more rocky or more icy body. This is all kind of speculation, but pretty clearly it just came through the atmosphere and left through the atmosphere, never hit the ground, and it survived. So it just shot through the upper atmosphere from entered around somewhere over Utah and left somewhere over Alberta, and was seen by a lot of people. Oddly enough, a lot of these reports of seeing this, they never were combined until sort of the internet age, basically, where people started putting stuff online about it, and other people started seeing it. Said, "Oh, I remember that. This was," and people didn't know what they saw, or had not thought about it, and so they really got actually more information from more places after, when there was a way for people to sort of communicate simply about it. But in any case, yeah, in the perigee, you can see in that little map there, the perigee was just over basically the Idaho-Montana border there, when it came closest to the Earth. I think they did estimate that number. The picture there is Coulter Bay Marina on Jackson Lake in the Teton National Park. So those are the Grand Teton Mountains behind it. So not only you have this amazing fireball, but you have this a spectacular view behind
Certainly,
it. And
yeah.
so this has
Yeah.
kind of made this picture very famous. I guess 57 kilometers.
Let's just see that again. There we are.
It's just
Yeah.
aliens passing through.
Right.
Yeah.
Anyway, no, they came. I mean, 57 kilometers. I mean, think of that, right? That's in space.
Amazing.
That's nothing. That's zero, right?
Yeah.
But luckily for Earth, I guess it wasn't zero. Not that this was, this was not one of those planet killer Earth, but it was still pretty big. It would have made quite a boom. I don't know if that was Tunguska. I think Tunguska was bigger than that. I don't remember.
Oh yes, it
offhand.
was. Yes.
Yeah, I thought so. Right.
Yeah,
But
yeah.
But
speaking-
anyway, quite
but
a
speaking-
sight. So yeah, go. So Andy, you had a video of this.
I've just shown it, Dave. We've already seen it.
Oh, well, okay. Oh, see, I'm looking at my presentation and not down at theirs. Okay, cool. Anyway, yeah, it was.
I mean, speaking of somebody who has seen a daytime fireball from here, which was quite amazing. It's one of the most amazing things I've ever seen, and I hope you all get to see a daytime fireball because they are absolutely stunning. Very rare, of course, to see them during the daytime. I was just lucky; just happened to look up and there it was. So.
Yeah, that's the other problem, right? You could go right over your head. I think Daz was joking, right, about the picture. You want to yell at the other people. There's people sitting on the dock there, walking on the dock. Say, just look up. Look up.
Yeah. I mean, some of them have got their back to it. So.
Yeah,
right, exactly. The fellow in the front is obviously watching it, but
yeah.
But
and I was saying, early on, person was standing there and had a camera in their hand. Nowadays, of course, you grab your phone and take a picture of it. But that was lucky. You didn't. You had to have a camera with you, and you didn't. It wasn't like you had a lot of time, and somehow this guy got this amazing.
Of course, we catch more of them now because of people have got cameras on their doorbells and things like that.
That's right.
So we see a lot more of them.
In London, everything's under surveillance, right? So
yeah, exactly. Of course, yeah. But also talking about things entering the atmosphere. Don't forget, over the next couple of nights, tomorrow being the peak, it's the Perseids.
Yeah.
Mm.
So don't forget to look up, and hopefully you'll catch a few meteors.
Yeah.
Yeah. People often ask, what makes people become astronomers? Well, it's simply because astronomers are born with a hinge in the back of their neck.
No, that's wrong, Andy. It's because we drink so much, we fall over and lay on our backs, and it was just staring at the sky.
Well, as I said before, astronomy and alcoholism, they both have two O's in the name. So
Yeah.
There we are.
All right. That's that helps. All right, lucky 13. All right, so August 11th, 1960. What is that? 66 years ago. Today. Cool.
Yeah.
Discoverer 13 re-entry capsule received. So this was the first successful recovery of a spacecraft from Earth orbit, and these were basically they were testing these spy satellites.
Of
And
course.
the idea was that they weren't able to really transmit television pictures from space. They just didn't have the technology, and of course you had still obviously 1960 things had to be small to go into space. You weren't sending up giant things. So they were experimenting with the idea, and they actually did this with the Discover program and later the Corona program, where they flew cameras up. And I talked about this at one point for another mission. They flew cameras up with film. And they would fly over the Soviet Union, and they would take pictures, and then they would drop the film off in a container, and it would parachute back to Earth, and they'd scoop it up in an airplane usually, but they tried this 12 times before Discoverer 13, and failed to recover the capsule. First off, to get it into space, then to get it into the right orbit, then to things kept going wrong. But they finally hit it on Discoverer 13. This capsule did not have a camera in it or anything. It just had telemetry instruments, so they could, track it and learn what they could about the mission and about the orbit and everything. But it went up, orbited the Earth, and dropped back down in a parachute, dropped into the ocean, and the dive team recovered it. It floated, and a dive team recovered it and brought it back. And it is now on display in the Air and Space Museum in Washington, D.C. Discoverer 14 was then launched the next month, and it actually was then that was scooped up by an airplane, which is what they did after that. They would just use an airplane recovery to scoop it up by the parachute. But this was the first. So the first thing actually retrieved from space, from a spacecraft. 1960, August 12th, the first passive communications were carried. The Echo 1 satellite, just a big giant Mylar balloon. They sent this thing up into space. They inflated it in space. You can see the size. You can see the car down there and the people down at the bottom of the picture. It's huge, of course, but they just inflated it in space. And of course, in space, it doesn't matter that it's a balloon. It orbits just like anything else. There's no atmosphere. There's nothing to slow it down. And then it would bounce radio signals off it. And this was, I guess, was kind of a big deal. I was a little young at the time, but that people could see this at night, this thing going over. And of course, at that point, no one was, satellites were very rare. And then a big bright thing like this, even rarer still, and people would see this in the sky. So.
This might surprise you, Dave. I saw it.
Yeah. Oh, you did?
Yeah,
wow.
I was, I think, 2 at the time, and my father took me into the garden and put me on his shoulders so we could look over the neighbour's fence because it was quite low in the sky. And I was only 2, but I remember clearly seeing it. So
boy,
it was it was a big event in those days. A satellite.
Yeah, satellite, right? That's what right, exactly. That's what I meant. This wasn't an everyday thing.
So it was in all the papers, and I saw it.
No, neat. Okay, cool. Yeah, I wish my dad had taken me to see it, out to see it also. But anyway, that's very neat. Our first selfie. Well, so August 14th, 1959, Explorer 6 took the first image of Earth ever taken from space, from orbit. It's not much of an image.
True.
Still the first image. Now, 2 parts of that. One, of course, the camera and the ability to even send telemetry back was very rudimentary, obviously, at that time. Well, you can see why they wanted to use cameras on their spy satellites when you see this, which was only a year before, right? This was the level of technology of actually sending signals directly from space. But it was the first picture taken from space. And the other part of it was, and it's probably hard to see that on the right there. This just shows where on Earth it is. The picture was taken almost completely over the Pacific Ocean, and even part of it was covered in clouds. So there's nothing to see anyway.
No, right.
In fact, anything you're seeing is probably clouds. Any differences, this sort of area here, that was clouds over Hawaii, and these are some more clouds, I think. The upper part was a lot of clouds, but basically, there was nothing really to see. Unfortunately, I mean, it would have been nice if there was, at least you could imagine you could make out the coast of Africa or something. But okay, anyway, still, first image ever taken from orbit. And August 14th, Lunar Orbiter 1 becomes the first U.S. spacecraft to orbit the moon. I've talked about lunar orbiters before. In fact, we had a whole show about lunar orbiters. And they, so this was the very first one, very first spacecraft from the United States to actually go into orbit around the moon. And it's successful. All 5 lunar orbiters were very successful missions, returned amazing pictures like the one on the left there. And Contour Labs. Okay, well, this is a stretch. The Contour spacecraft, which was supposed to go and visit a couple of comets, and it was a pretty cool mission, and it just failed. Contact was lost. What happened was they turned off all the telemetry. Not clear exactly why, but then before they repressurized, they were pressurizing the tanks in order to do its burn while it was in Earth orbit, to do its burn, to go and visit Comet Encke, which is the one shown in the middle there. but when they tried to get in touch with it after that, they couldn't. They still they don't know. They did a big study of it, but oh, I'm sorry. I said pressurization of the tanks. That was wrong. I'm sorry. It was a solid rocket motor firing,
Oh,
and for some reason they had turned off the telemetry. Don't know why, but anyway, it doesn't. They actually changed their standard operating procedure after that to keep telemetry on at all times when they were doing any operations, so that they would at least have a clue if something went wrong. So they believe that maybe the exhaust plume from the solid rocket motor overheated the spacecraft, but they're never sure. They came up with a bunch of possible causes. That seemed to be the most likely one, but they never did know. But anyway, that was just 24 years ago, and I believe that's all I've got. Yes, it is. Okay.
all right, great.
So,
Yeah, thank
all
you.
right, thanks. That was a long one. Sorry. I hope I hope you had time for that.
Thank you very much, Dave. Really interesting as always. So we'll look forward to the next one. And there we are. Okay, let's just do a few housekeeping things before we move on. Firstly, let's talk about tomorrow, the total eclipse of the sun tomorrow. The plan is, weather permitting, and I have to put that in big glowing neon letters, weather permitting, Daz will be running a live stream on the channel starting at 5:45 UK time tomorrow. He's going to be bringing you the eclipse live from his garden with a C-star telescope. So we hope that you can join Daz for that. I will be elsewhere. I will be viewing the eclipse from not far from here at a friend's barbecue. We do have a weather forecast of sunshine and cloud for that time of the evening, so fingers crossed. But I will be taking the telescope and camera and everything. If there's anything worth seeing, I will drop into the live stream at some point during the eclipse. Lou is guiding a party of people from the US around Spain, and tomorrow they're ending up at Rioja in Spain for the eclipse, and he hopefully will be joining the stream at some point from Rioja in Spain. So we hope to have one UK stream and two Spanish streams on the channel at some point. But at the moment, Daz is aiming to go live on the channel at 5:45. Is that correct, Daz? You're on mute.
Yeah, because it starts. First contact is just after 6, and it runs literally for 2 hours. I won't be able to cover it all. I'll be able to cover it from 6 o'clock till about 7:30, maybe a bit beyond, and that will cover the when we get the maximum coverage. So I think it's about 93 +% we're going to be here. So it's going to get very dark here, very cold as well as these things happen. But also, as I was saying to Andy, the direction the sun will be going, it's in line with a rookery. And of course, we all know that when the sun goes down or goes dim, all the rooks decide they're going to come in and roost. But before they do that, they put on a flying display. There's probably about nearly 100 plus rooks there. So hopefully we will see the rooks flying into their rookery, depending upon how much of the sun's left. And of course, then once the sun starts to lighten again, they'll all wake up and they'll do it all again. Only to about sort of like an hour later, or do it again because it'll be nighttime then, because it's going to be quite low for me. But unfortunately, my neighbours haven't been trimming their trees, so as soon as I lose it, then we'll stop the stream. But don't look for on YouTube for a fingernail, because thumbnail, because what we're going to do is just going to be on the spur of the moment. So look out for your notifications. And hopefully we might get some from Lou. But everything's dependent on technology and the weather. So yeah, look forward to it if it works.
Yeah, thanks, Daz. Yes, there won't be a live stream on the channel in advance that you can look at. So the best thing to do is just go to the channel around 5:45, and you'll see us live. We didn't want to create a live stream in advance in case nothing happens and we end up with egg on our face
again.
Yeah, if there's bad weather and we have to cancel it. So keep an eye on the channel, watch your notifications, and all being well, then we'll go live at 5:45 tomorrow, and Lou and or myself, or neither, will drop in at some point during the live stream from Daz, and we're very grateful, Daz, for you to take the time to set all this up.
That's all right.
And we all have our fingers crossed. And as Daz said, tomorrow is the peak night of the Perseids, of course. Theoretical maximum of 100 meteors per hour, although I've never seen it get anywhere near that. So there's a new moon this year, so the moon won't interfere with the Perseids viewing. Don't forget, a lot of people think that it's tomorrow night and then nothing. The Perseids do run till the third week of August, I think. So even if it's cloudy tomorrow or you can't get out, just keep looking over the next few days. You will see some meteors, although obviously you're peak, so not as many. The best time to look is after midnight, really. That's when they really start to pick up, or not. But it's not often we get a new moon for the Perseids peak.
No, exactly. So fingers crossed that we get clear skies for that.
And of course, if you do manage to get any photographs of any Perseid meteors, then do send them into the gallery. And talking of which, we're now going to go over to Roger. That was a clever link, wasn't it? You have to say.
Absolutely.
Yeah, we're going to go over to Roger now for the night sky and the gallery. Take it away, Roger.
Hey.
Yay! Okay, here we go then for what's in the night sky. Da, da, da.
Can I get some music for that? You got to get some music.
All right then, we'll see about that. Right, so we're between the 11th and the 17th of August, heading on our way through. So as everyone's aware, the new moon will be tomorrow, and gradually working its way into the new present phase of the what's going on. So this is what will be happening in the night sky over the next few days. Although if you look directly up, without spraining your neck too much, you'll see the summer triangle and see Cygnus and Vega almost overhead. And we've also got Altair completing the summer triangle. And then obviously over to the left there, we've got Andromeda and Pegasus there with the Andromeda galaxy getting nicely positioned. And we've also got Saturn coming out through the night skies now. So things are all looking quite promising. And as you can see here, before sunset, we've got Jupiter and Mercury very close together, although it's too close to the sun to be able to see anything properly of that. And then we've also got, following on, we've got the moon just a few days old there, and also Venus, although that is can be a bit awkward because it's almost at the same latitude as the sun. So when the sun has set, Venus is just a degree or so off the horizon as well. So never mind. But as you see, through the night, we've got Saturn rising up quite nicely. That's in Pisces. And then over on the other side, through Gemini, we've got Mars coming out through. So anyone wants to see a tiny little Mars, that's also going to be starting to become a good object to be seen. But obviously, we've only just got a few hours before daylight starts to interfere with the visibility. But we'll take what we can until later on in the year to start observing Mars again nicely. So, as everyone has spoiled alert, we've got an eclipse and the meteors of the Perseids coming out through. So we've got, obviously with the Spain being on the best path, although we do have it coming through Greenland and over on the western side of Iceland. and coming down through. We will get a good 90% plus of it partially, and obviously, as everyone has been saying, it's going to be very difficult to observe without any safety glasses for solar observing. So this is what we've got this year. The eclipse going right the way through. In fact, it does start in Siberia at some point. So although it's only a couple of minutes for this duration, and we will be able to get a good proportion of it, unfortunately, it won't be as long as the one that's going to be next year, which is also in August, although it will be at the beginning of August, and it's in the early-ish, middle-ish part of the morning. So that's not too bad. And as I've got, London will be getting about 42%. So we're not as well covered, but it will be another eclipse. So
here in Spain, my plan is to travel down to the very southern tip of Spain from where totality is visible, sort of on a line across Gibraltar and Cadiz. So I'll be going there next year, and I hope to bring some live coverage.
As opposed to 2 minutes this year, it's almost 6.5 minutes for next year. So it is a better eclipse time-wise, but you obviously have to pick your spot to be able to get to see that. So it's a little bit more awkward in Spain. So you'd probably have to go to Algeria or go through to Libya, Egypt, and down through the Middle East there to get the totality, unfortunately. Anyway, so we've got up to some of the parts here. So the contact roughly around London is about 6:15, and then about an hour later, the maximum of what the partial eclipse will be is round about between 10 past and 7:15, with a end of contact around about an hour later. But by that time, the sun will only be a few more degrees off the horizon. So a good low horizon is probably essential, really. So as it says here, Britain won't see anything like this again until 2081. So I think that might just about knock most of us out, I think, for that one. So as you can see, everyone's wearing the regular, the proper solar glasses, which people have decided to start buying, but can't seem to find them now because it's all lastminute.com, realizing that tomorrow is a good clear day for a lot of the UK. So we've, as you can say, we've also got the peak of the Perseids. So as soon as darkness finally happens after the eclipse, we'll be able to start to see the peak of the Perseids. And I did notice a few random ones a few nights ago, so things should start to rapidly wind up quite nicely. So that should be a good opportunity there. But this was how the sun was looking today. A few little sunspots, nothing dramatic, no great prominence activity, and no large coronal holes, although there is a little bit over on the northern bit directly facing us, but nothing as dramatic of what we have seen throughout this year already. So
yeah, today when I was practicing for tomorrow, using the Sea Star, there's only one sunspot that's actually visible, and it's right on the eastern limb, about sort of like 10 o'clock-ish it was.
Yeah.
But as you said, there's no very large coronal holes visible at the moment. There's a few sort of like flare prominences on the face of the sun. You can see them here. Well, I'm using my cursor. You can't see them. The dark lines, they're usually where the
around
the
about
flares,
here.
but that's right. They're looking directly at us, and they can sometimes flow off and give us a CME. But we're at the moment we're in. We seem to go through this phase now where we have 2 weeks of high activity, then 2 weeks of virtually nothing. at the moment. So in about a week's time, we'll have some. You can see they're starting to come round now on the eastern side. If you look at the right hand thing, you can see the flares coming round. So yeah, but so next week we should be getting some more action, hopefully.
Okay, so we're now going to go over to the gallery.
Hey.
Beware of those flying meteors. Okay, so we've got our usual quantity of pictures from our regulars, and we've got another beautiful picture from Michael Murphy of the Sun on the last day of July. And thankfully, he's labelled up all the sunspot groups. So thank you very much for that.
Yay.
So
As I
hopefully,
said it last week, we had quite a few sunspots on there.
So maybe we'll see 4498 again on its return.
Yeah,
depending on
a week and a half time.
How it goes. So all done. And then we've got an interesting picture of the moon over Plus Garden Abbey, which Ian did for us and sent in. So here we go.
Oh, that's
nice.
A nice silhouette. So there we go. Well done, Ian.
It also seems to be a very bright object. At the 9 o'clock, there's a star. Don't know if that was one of the planets. I have to have a look what the date was. Very interesting. That's nice, atmospheric.
And one from Michael of the moon, done with his Z7 and his 500 mirror lens, which he will be using tomorrow to record the partial eclipse.
Yay!
And this is what.
That's nice.
That's nice. Yep.
Not bad for a 500mm caddy dioptric.
Yeah, cropped as well, of course.
Yes, well, that's fine.
Yeah.
Wow.
Got some nice detail right on the Terminator there.
Yeah, that's nice. I like it. I like the Terminator's just entering Mare Crisium.
Yeah. Well done, Michael.
Thank you.
Yeah, great image, Michael.
Hey.
And and then we've got another one which was done on his iPhone.
Yeah.
On a tripod. So he's managed to do some nightscapes there.
Yes.
That's nice.
You can just
nice.
You can just see Delphinus to the left, and Sagitta at the top, and Altair in the middle. You've got a couple of
yes, all your favourite small constellations.
Hey! And of course, there's a couple of.
There's probably got about 6 there that you've got already done.
Those satellite trails, I don't know whether those would be Starlink, would they? Probably.
Oh, probably.
They go in all directions now.
Yeah.
They're all over the place.
Yeah.
Well done. And here's one of my Milky Way shots from the garden that I took.
That's nice.
That's lovely.
Oh, wow. Yep.
That was 25 seconds. Oh, wow.
Yeah.
Jeez.
Well, I didn't want to make it too long, otherwise you start getting star trails.
Yeah, exactly. Yeah. So what lens was that, Roger?
Well, it was on an APS-C camera. It's a 12mm, so it's like an 18mm on a full frame. So still reasonably wide.
Yeah, that's right. Yeah. Well done.
So I have done them as panoramas, but you sort of have to take about 18 or so to get it all in for the arch. But, not too bad. And earlier on this month, I did some solar imaging, just for a change. And we've got hydrogen alpha on the left and a calcium inverted solar image on the right-hand side.
All right.
Lovely.
Wow.
Very nice. Some nice prominences there.
I love those prominences. Yeah.
That's why I took them, because they were quite good. So this was a few days. This is about 2 days after the ones that we saw earlier on.
Yeah, very prominent.
Yes. So there we go. And then I did the obligatory lunar image, but this was a daytime one, so
Daylight, yeah.
Yeah.
a daylight image.
You got your finger across it. We only got half of it.
I know. That's on its last quarter. So,
Of course, it is daylight on the moon as well.
Oh,
yes.
yeah.
Okay, so there we go.
Thank you,
Excellent.
Roger.
Thanks for that,
Thank
Rog.
you very
Yeah.
much indeed. Yeah, so anyway, talking of the eclipse, we're really blessed here in Spain because not only have we got tomorrow's eclipse, we've got another total eclipse next year, and in the following year in January we've got an annular eclipse.
Wow.
So,
Oh, jeez.
yeah, so ha
There will be a lunar eclipse as well later this year.
Yeah,
as well.
yeah, there will be. Yeah.
That's right. And it's an unusually deep lunar. It's a partial eclipse, but it's an unusually deep one because 92% of the moon is going to be covered. So it's a really deep partial eclipse, almost total. So we'll keep you posted on that. Anyway, if you have any images you would like to send into the gallery, then it's simplicity itself. Attach them to an email, one image per email, please, and mail them to gallery@spaceoddities.space. That's gallery@spaceoddities.space. We expect to be inundated with photographs from you of tomorrow's eclipse and lots of Perseids later on in the evening. So get those images into the gallery because
no pressure.
Yeah, no pressure. No, but if you don't, we'll send the boys round, and you wouldn't like Daz when he's angry. So there we are. All right. So anyway, if you would like to support Space Oddities, then you can buy us a coffee by scanning this QR code or clicking the link that's just appeared should have just appeared in the chat. And that will take you to our Buy Me a Coffee page where you can keep our caffeine levels topped up, if you would be so kind. All the money we receive from kind people like you goes towards keeping the channel running. So if you like the sort of science that we do here on Space Oddities, quality science, we like to call it, then please support us by buying us a coffee. Only takes a minute, won't cost much, and you'll make us very happy, and you will enable us to keep going on YouTube. So thank you very much for your support. And you can also, of course, join our Patreon. We have a Patreon. Couldn't be easier. Very, very simply, go to patreon.com/Space Oddities. Join the community there. For just a few pounds a month, you get all our presentations that we give you on Tuesdays and some other goodies as well. And you are helping to support the channel directly as well, for which you have our eternal gratitude, because we've been going for 4 years plus now, and would like to keep going for another 4 years and bringing you the wonders of the universe. So help us out, join the community, and you can also join the. You can also support us by buying the Space Oddities t-shirts and hoodies. There's the QR code for the t-shirts. Well, that will take you directly to our merchandise page. The t-shirts are £20, including UK postage and packing. We also have hoodies available at the same link, actually, which are £40 plus, including UK postage and packing. So there we are. If you're outside the UK, add £10 to the total value of your order, please. And there are the hoodies. So there we are. Okay.
Can I just jump in, Andy? I don't think Kenneth's in the chat. I haven't seen them.
Yes, he is.
But he was the winner of our quiz. I've received a notification today. It should be with you on the 13th. I did send you an email, but just to let you know, you should be receiving it on the 13th.
You're watching Kenneth. I can't see Kenneth in the chat, actually.
No, I don't think he was. I haven't seen him.
Well,
today.
I did say to Kenneth it would probably take a week or so because it's
Well, I've got
through Norway anyway, so it's fine.
Yeah, I even sent it in Norwegian. So yeah, so we probably won't understand a word of it.
No.
So,
Right.
Wondering why he's getting lobsters delivered or something, but
yeah.
But no, so it's on its way.
Right, thank you, Des. Thank you very much, and congratulations again, Kenneth, for winning last week's quiz, which we hope you all enjoyed. And there we are. Okay, it's time for that part of the evening now. It's time for Space numbers of the week. So if you haven't seen this before, very simple. I will give you a number associated with something to do with the universe, and you have to work out what that number relates to. So let's go over to the first space number of the week, which is 4 tons. Can you guess what that refers to?
4 tonnies. So we're talking about mass. So what could be 4 tons? Is it a satellite or something?
It's something related to space exploration. That narrows it down.
The weight of the Nancy Grace Roman telescope?
No, I'm going to have any other suggestions? No. All right. This is the approximate mass of the spent Falcon 9 upper stage that struck the moon last week. It hit the moon at roughly 5,400 miles an hour near the Einstein crater. Now, we can't bring you any video of that because there isn't any, because it didn't really make anything visible at the time. There are a couple of people I've seen that managed to catch very blurry images of some sort of impact, but certainly there's nothing that's worth showing.
Yeah, I did see that they, I think it was either the Japanese or Chinese or somebody managed to catch it on a infrared.
Yes, that's right.
Yeah, so
they found the crater. Is that? Yeah, or the crater or the actual impact?
No, the actual impact. They got.
Oh wow! Okay.
Analysis of, and it reveals sodium and lithium in the plume.
Yeah. Okay.
Sodium and lithium.
Yeah, they think the lithium actually may have come from the spacecraft batteries.
Batteries.
Could have done, yeah.
Although there is lithium on the moon, but they think in this case it came from the spacecraft batteries. So there you are.
Well, it's too bad. Too bad they didn't have any seismic stations running then.
Yeah.
You know, they used to shoot the Saturn upper stages. They dropped those onto the moon to, have a known impact. They knew the weight, they knew the angle of impact, they knew the speed, and then they could use it to calibrate their seismometers. Just a seismic source on the moon. So it was a useful thing. But anyway.
So next space number, 18 meters.
Oh dear.
Meters.
Is it the distance something's travelled very slowly?
You're getting there, but you're completely wrong.
Thank you. 18 meters.
Any ideas, viewer? No.
Height of a rocket or something?
I'll give you a clue. It's connected to the previous space number.
Well,
diameter of the crater that was left by the
exactly
impact.
It. Yeah.
Okay.
It's actually the approximate diameter of the new lunar crater the Falcon 9 stage is expected to produce. Lunar spacecraft, including the Lunar Reconnaissance Orbiter, may eventually image the site. So it's not a priority, but they may get around to having a look. So there we are. Okay, next number. Oh, there we are. That's an image of the actual impact site.
You can see the debris field as well.
Yeah. So there we are. So that's
neat.
We have to say, because there've been loads of people on social media having a go at SpaceX and Elon Musk because of this littering on the moon. It wasn't intentional. It was accidental. It wasn't expected to end up on the moon. But there you are. These things happen. It wasn't the first, and it won't be the last.
That's right.
100,000.
So next number is 100,000. Now
100,080.
Yeah, this actually relates to something to the CD 35172722 Exomoon I was talking about earlier.
100,000.
How much dimmer it is than its brown dwarf companion?
No.
Okay.
Nice guess. No.
100,000 so many solar masses less or something, or
No,
planetary masses, or
no. I'll tell you, it's related to the taxonomy problem, because this is the number of transiting exoplanets that the Roman Space Telescope is expected to detect during its lifetime. So we've only got 6,000 exoplanets in total now.
Wow.
But this is just transiting exoplanets it's expected to discover, not the radial velocity method that the so-called Exomoon was discovered by. So this is just planets moving across the face of their parent stars, and the Roman Space Telescope is expected to detect 100,000 of them. So if we have a problem categorizing 6,000 planets, this is really going to put the cat among the pigeons.
It does, and it shows how important, like you were saying earlier, for statistics, because that's going to be a lot of numbers to do statistics on.
Classifications.
Yeah, absolutely.
So Ian says it's the number of Dalmatians in space now, because that would be 101,000.
Yeah, it would. Yeah. Okay. Right. Next number is 93.6%.
Oh. That's for the eclipse tomorrow, is it? Down in Cornwall?
No.
93.6%.
I did actually mention this a few minutes ago.
Oh.
No.
The number of Falcons that have not crashed into the moon.
It will be the percentage of the moon eclipse.
Oh, yes, right.
The partial eclipse of the 27th, 28th of August. And it's going to be seen by an estimated 1.5 billion people. So look out for that on the 27th, 28th. We will try and do something for that, obviously. So there you are. Next one, 11,211 days.
Is it an orbit?
No.
That must be. No, that can't be, can it?
Well, it's not till Christmas, that's for sure.
No, definitely not.
We could only hope.
Is it a time to another eclipse or something, or?
No, it's got nothing to do with eclipses. I'm going to have to tell you this one.
Day
is Soho's day 11,211 days since launch. That's more than 3 decades. So the amazing SOHO, that's the Solar and Heliospheric Observatory, observing the sun from, I think it's L1. For more than 3 decades now, performing flawlessly. Wonderful spacecraft. After 3 decades, it's still giving us enormously important information about the sun. It's seen umpteen comets actually crashing into the sun from its vantage points. It's discovered all sorts of things, and when Daz does his solar roundups, you often see SOHO
images.
Images,
those lovely images of solar flares and coronal mass ejections.
Yeah, as you said, it's been up there for 3 decades.
Yeah,
and like you say, the data is given. It's absolutely fantastic, but it is showing wear and tear, and the engineers and the computer people are really fantastic at keeping this thing going. It's basically a baler twine and sticking plasters to keep it going, but it's absolutely the longer you
looks like. There you are.
Yeah. I thought it might be the lifetime of mission, but I could not think of what mission. And there you go.
Isn't that a fantastic achievement? I mean,
that's
to my
really
way of
something.
thinking. To my way of thinking, it's a bit of a unsung hero. So,
there's a lot of things out there that have been out there for decades, giving us vital information that we don't know about. Well, we know about, but other people never heard of.
That's right.
Yeah,
so
I mean, Soho's been fantastic.
So that's the space numbers of the week for this week. We're going to go over to Michael now, because NASA. The great thing about, in my opinion, one of the great things about Jared Isaacman heading NASA is that he's going out of his way to make sure that NASA give regular updates on what they're up to. And they've been giving monthly updates on the progress of returning people to the moon, the Artemis program. And this month's update was all about moon bases. So, Michael.
Yep.
Take it away.
Okay, you can see that.
Yes.
Let me find. What am I doing? Oops. Hang on a second.
So there's a lot coming up in preparation for creating a permanent moon base by the early 2030s.
Yeah. Okay. Thanks, Andy. So yes, this is the latest information, and it's actually based on NASA's announcements only last week, I believe, on its August 2026 update. And this is all about the robotic missions that are going to the moon. As it says here, 20 plus robotic landings before any astronaut sets foot. So making sure that everything is in place before astronauts get there. With obviously safety top of the list. Okay, the mission, a resilient outpost near the moon's south pole, built for science, technology, and eventual human operations. Phase 1, between now and 2029, more than 20 robotic landings, each incrementally advancing capabilities and validating systems for those that follow. Commercial landers, Blue Origin, Firefly, Intuitive Machines, and Voyager Technologies, all targeting delivery of foundational architecture by 2028. So I'll go through those missions now. So first of all, you've got Blue Origin with Blue Moon Mark 1 lander Endurance, surviving the void. This is their prototype lander that's launching hopefully later this year. It passed thermal vacuum testing at NASA's Johnson Space Center, verifying it can operate under lunar-like conditions. Structure, propulsion, and avionics fully assembled. Communications checkouts completed with NASA's tracking and data relay satellite system and the Deep Space Network. Next step, loading cryogenic propellants before launch integration. The mission, called Endurance, will demonstrate precision landing and test autonomous systems for future moon-based missions. The next spacecraft is being built by Firefly Aerospace. This will be the first American landing on the moon's far side. Blue Ghost Mission 2 is a 22-foot tall dual spacecraft system. Blue Ghost stacked on Elytra, I think it's pronounced, Firefly's orbital spacecraft. It's nearly 3 times the height of Mission 1, which successfully landed in 2025. Far Side Science, planned to be the first American landing on the moon's far side, a uniquely radio-quiet region, ideal for studying far-side geology and the cosmic dark ages, when newly formed stars were just becoming visible. Payload and Heritage carries 3 NASA payloads. It uses proven subsystems from Mission 1 to accelerate development and reduce risk. So the Elytra spacecraft will stay in orbit while the Blue Ghost will land, and the Elytra will operate as a relay as the lander's landing on the far side. Okay, next company is Intuitive Machines. In IM-3 Trinity plus the moon's first data relay satellite. Nova C third landing. IM-3 represents Intuitive Machines' third Nova C lunar landing, building on a heritage of lunar surface operations. Altus 1 relay satellite is the company's first lunar data relay satellite, flying alongside the lander to extend communications coverage. And the target for IM-3 is the Rainer Gamma target, first mission to explore lunar swirl. Excuse me. the mysterious rain gamma magnetic anomaly, and carrying 5 NASA additional payloads. Just excuse me. The next one is Voyager Technologies, the biggest commercial payload ever sent to the moon. Designed and built by Astrobotic Technology, Voyager Technologies completed its acquisition of Astrobotic in July 2026. Griffin 1 is an infrastructure class lander targeting a late 26 launch, currently undergoing environmental testing at NASA's Jet Propulsion Laboratory. It will transport the largest commercial payload ever delivered to the lunar surface. 5 NASA payloads mounted on the Astrolab FLIP, or the Flex Lunar Innovation Platform rover, advancing surface mobility, technology demonstrations, and long-duration lunar operations. The next is Northrop Grumman, surviving the lunar night. Northrop Grumman is repurposing power, avionics, and thermal technologies originally developed for the cancelled Lunar Gateway, Habitation and Logistics Outpost, or HALO, module into 3 lunar infrastructure demo surface missions. And this module was built for the Lunar Gateway in Italy, and now being repurposed for the lunar service rather than an orbital station. So the HALO heritage hardware, 3 technology demonstration payloads repurposed from power and avionics hardware originally developed for Gateway's HALO Habitation and Logistics Outpost module. Survive the night systems designed to endure multi-day shadow periods and the moon's extreme temperature swings, a critical capability for permanent lunar operations. Shared surface power infrastructure that will support critical payloads and other moon base assets, a foundational building block for permanent human habitation. And how is this made possible? It's all about the CLIPS, NASA's CLIPS program, this lunar supply, the commercial lunar supply chain that makes it all possible. NASA's commercial lunar payload services initiative enables rapid, frequent, and affordable access to the lunar surface, turning one-off missions to a reliable supply chain. Compounding effects, each commercial mission builds on the last, reusing hardware, validating systems, and reducing risks for the missions that follow. Recurring deliveries are the engine for a permanent lunar presence. Okay, what will robots do before humans arrive? Validate landing, power, and navigation or autonomy. Instrument deployment, place sensors for radiation, temperature, and dust. Build power grids and data communication networks, and incorporate findings into base architecture. The moon base is actually being built right now. Here's what's next. Late 2026, Griffin 1 or Voyager, from Voyager launches with the largest commercial lunar payload ever. By 2028, all 4 commercial landers deliver foundational moon-based infrastructure to the lunar surface. And through 2029, 20+ robotic missions complete phase 1, paving the way for a sustained human presence at the lunar South Pole. And anyone can read all about this on NASA's website. They've got all the latest information on there. So thanks for that.
Great, thank you, Michael. Exciting times ahead. Now, the only thing that we must say as a caveat is that, given the rate of failure over the last few years of lunar landers, we shouldn't expect all of those to be successful, but we hope they will be.
Yeah.
So how will they communicate with the far side probe?
Yeah, well, at least 2 of them will have their own orbital
Relay station.
stations to relay communications back to Earth.
And
sorry.
Europe also has plans to establish a network of relay satellites on the moon.
Yeah.
So it's all coming together.
And guess who NASA chose for their lunar communication satellites? SpaceX.
SpaceX.
Yeah, they've chosen Starlink for their laser communication.
Starlink around the moon as well.
Yeah.
Okay.
Yeah. So Ian also says, how long will individuals be on the moon until they have to return? Is there an upper limit?
Yeah, we don't know, right?
We don't know.
Yeah, because I mean, the thing is, you're
really been done for any length of time.
Yeah,
So,
I mean, you're exposed to radiation and things like that. You're exposed to the.
It's supposed to be a continuous presence. So, I believe like the space station is.
Yeah.
So
yeah, but it's not like the space station. You are outside the Earth's magnetosphere.
Exactly. Yeah.
Very little protection.
Yeah.
Yeah. I don't know. That's a really good question, actually. I don't know how long they were planning to leave people there.
No.
I would think at first it would be pretty short stays.
Yeah, I would have thought so. Like it was with Apollo.
I mean, they need the habitats, and they need to be radiation proofed, and things like that, because the radiation in that is basically the main problem.
Right.
I mean, Paul also says, I just didn't know if if relay satellites were already in place. No, they're not.
Right. The Chinese have one.
Yeah. Oh, yeah. Of course they have.
The Chinese have one that they used for their far side lander.
But that's what the gateway is also going to be for. And it says, and also Derek says, all this, another reason to keep Jodrell Bank. Yes.
Yeah.
Yeah.
Exactly.
The revolution starts.
Yeah. Yeah. See our previous live stream for details. Okay. So thank you for those contributions. I think, it's all moving forward a lot quicker than people think. And we've got lots of robotic missions coming up over the next couple of years. And of course, we will bring you all of them on Space Oddities. Okay, we're going to, as time's getting on, we're going to, Paul Roger, we're going to move his constellation of the week till next week. So
because we know that'll take some time.
Sorry about that, Roger. Blame the clock.
All right.
So there we are. So we'll let these.
I won't be here next week with the history stuff, so you'll have a lot more time, Roger. So.
Okay. Yeah, Dave won't be with us next week, as he will be in the air, in a plane, obviously not flying.
In the air tonight. That's a song, isn't it?
Yeah. So anyway, just to wrap things up, we hope to see you, all being well. Don't forget, it's all weather dependent. All being well, if the weather's okay in the UK, Daz will be live streaming from 5:45.
Fingers crossed. Cross your fingers,
UK time. So keep your fingers crossed. Have a great eclipse, everybody, whatever you're doing for it. We want to see your photos, and send them into the gallery at spaceoddities.space, and also any of the Perseids that you managed to snag as well. So there we are. Thank you very much for watching. Have a fantastic week. It's a great week for astronomy. And we'll bring you everything about it, and we'll talk about it next week. So from all of us at Space Oddities, be kind, look after each other, and we will see you, if not tomorrow, then definitely next week. So all the best to you, and thank you.